Hello and welcome to Software Polls, Building Java Desktop Applications, and I'm John McNeil. And in this session, we're going to take a look at extending our RESTful web service that we covered in a previous session. In the previous session, we added authentication into our basic authentication into our web service. What we're going to do in this session is we're going to extend that so that once we've authenticated, we're going to return a JSON Web Token, and then we're going to use that JSON Web Token to allow us to make calls to other endpoints in our web service API. Let's have a look at the reasons why we might want to do that. Because if we've put authentication in place, why don't we just stick with that and use that? That seems like it's adequate. If you consider how an API is used or web service is used, let's take, for example, or let's assume we have some sort of web service that allows us to call back all the emails we have in a mail system. This is just a hypothetical example to try and explain what the challenge is here. So what you'd want to do, and let's assume it's a multi-tenanted service, so there's everybody's emails all in one system, and obviously when you call it, you need to prove who you are, so you only get back the emails that are yours. It's a rather contrived example, but let's run with it. So you power up your email client and it makes a call to the web service to pull back all the emails, and then you open up an email and then you do some action and you come back to your list of emails and so forth, and the day, and you go through the day like that. So what you're in effect doing is you're continually calling that web API service, and that specific function call to give me a list of the emails in my inbox. If of course then you change to have a look at the emails that are in a folder, for example, that may be a slightly different API call within the same web service, so you'd still want to use the same authentication credentials that you've got. So if you had to authenticate every time you made a call, what you're going to be doing is you're going to be continually asking the user to enter in their username and password. Or alternatively, what you'll then need to do is once they've entered it in once, you'll need to hold that username and password somewhere that's in clear text so that the application can reuse it every time it's making an API call. It can send across those credentials. That obviously represents a risk. It's never a good idea to hold your password in clear text on a system, because other people can get hold of that and then make use of it. So, and it's also not generally a good idea to continually keep sending across your username and password, 20 or 30 times to the same service in a relatively short period of time. You want to reduce the number of times you have to do that, so there's less risk of somebody intercepting and being able to make use of those details. Even though they will be sent across HTTPS, you are still sending them multiple times, so you're increasing the profile or the envelope profile for which you can be attacked, and those details can be obtained. So that's the problem that we've got. We're holding the username and password in clear text somewhere, and we're sending it multiple times, so increasing the chances of it being intercepted and hijacked. So what's the alternative? Well, there are many alternatives out there, but one of the alternatives that has been developed is the idea of using a token. And so the way this works is you call an API system, and it requires you to prove who you are, and you haven't proved who you are, so it denies you access. So within the web service, or within the service that's available, there is a feature for you to be able to go and log in. So you call the login service, you provide a username and password. Once that's checked and approved, then what they'll do in return is they'll send you back a token, in this case a JSON Web Token, because that's what we're talking about. You then take that token and you pass it in the header of all subsequent calls that you make to the API that require you to prove who you are. When the call is made, the token is received at the API end, the web service end, and that's validated. And I'll come back and talk about that a bit more in a minute. And if it's valid, then they'll return the data to you. So that's the model that happens. You call it, you're not authenticated, you're denied, you log in, you get a JSON Web Token, you use a JSON Web Token to make subsequent calls, and you get the data. And the token doesn't contain your password. So if anybody hijacks it or can interrogate it or read it, which they can with JSON Web Token, it's easy to do. There's no way of them obtaining the password. Challenges with using JSON Web Token. So the first one is let's just look at what is the JSON Web Token. So the JSON Web Token, and I'm not going to go into too much detail because there's loads of information available out on the web about this, but it's made up of 3 parts. It's made up of a header, a data payload section, and a security section. So the header you can read, you can easily decode and read it, and it will generally tell you 2 bits of information. One is what type of token it is. In our example, it will be a JSON Web Token, and what algorithm was used to sign the token. And that's important because when you come to validate the token hasn't been interfered or tampered with, you'll need to know what algorithm was used so that you can use the same algorithm. The payload, the data payload section, is a whole load of data that as the designer and the builder of the token or the system, you can determine what you put in there, but there are some standard things that are put in there. So one is the expiry date of the token. Now, I'll come back onto this point in a while, but that's important, the expiry date. You'll sometimes get a valid from or a created date. You'll get the organization that owns or supplied the token, or that the token's on behalf of. So in my case, that would be softwarepulse.org because that's my development domain name. And then the application that it's going to be used for. So in the example we're doing in this series, I might just say it's the person API, because ours is just a fictitious example. And an ID, quite often you'll get an ID, a unique ID, so that token is different from any other token. Now, that information that goes in the payload, again, anyone can decode it and read it. So you don't want to put any sensitive information in there. Oh, one other thing that's quite often put in there is the user role. If there's a role in that particular, when you authenticate with that service, if you've got like an admin role, they might put that information into the payload as well. But like I say, you don't want to put anything sensitive in there because it's freely available. Anyone who intercepts that token will be able to read the information. And I have done a previous video on a group of developers and myself put together a small application to decode JSON Web Tokens. I'll put the link in the description so that if anyone who's interested, they can take a look at it. And the source code is available on GitHub as well. But if you look at the video, you'll get all the information you need if you're interested in that. So that's the data payload, some information that you send across that the web service can then use to make decisions. But like I say, it's in plain text, anyone can read it. And in the last section is a security section. Now this is a code, an algorithm that is generated, a code that's generated from the algorithm that we mentioned in the header. And the way it works is when you want to create a JSON Web Token, you pass across, you set the header fields, you pass across the payload data section into the algorithm, and you use a key or a passphrase that the service needs to keep secure. And then you can generate a web token. And if anyone then tries to tamper with the header information or the data payload information, when you get the token back and you run it through the algorithm, you'll end up with a different set of information. And that's how you know it's been tampered with. So if you were to try, if you were to take a JSON Web Token, read the payload stuff, and then make a change to something or other, you'll find that the overall token value changes. And then if you were to run it through an algorithm with the passcode that you use to create it, you'll find that you'll get a completely different set of values, and the two won't match. And that's how the web service would do its check. There is a slight nuance there. I might touch on it in a while, but because the only things that create the token are the data payload and the key phrase, the token will never expire. That it will always be true, it'll always be valid, and that's why the expiry date is so important. So when you're creating your web service and designing your service, you need to think carefully about how long you want to have the token valid, because obviously if you're sending the token lots of times, because we've just said you're making lots of calls to the web service, if somebody hijacks the token, they could in theory spoof who you are and gain access to the system by using your token. Again, hopefully you're passing it across HTTPS, so it's going to be harder for them to do that. But you need to be aware that you don't want to have a never-ending token, because then if anyone gets hold of it, they will have access to the system. So you might set the token to 4 hours or a day or 5 days or whatever. You just need to be mindful of that. The beauty about using a token-based system as opposed to a session-based system, so if you're using a session-based system, what you do is, apart from going against what web services are supposed to be about, is you would send, you'd authenticate against the web service, and they'd create a session token on the server, and a session ID on the server, and then they'd send back an ID in some sort of token or cookie, and you'd replay that back to the web service, and then they'd look up and find out all the information to do with your session on the server. And the challenge with that is, in this modern world with clustered and scalable solutions, you never know which server you're going to be calling that's supplying the service. There can be many endpoints that you can call that will all provide the same service and have access to the same data. And what you need is, for whatever information you provide across there to prove who you are, for that server to be able to understand that's a valid request. The beauty about JSON Web Token is, so long as all the servers that are providing the service have the passkey, they can simply take the token, look up the algorithm, put the token and the passkey into the algorithm, and they should end up with the same code as you have supplied. So that supports how you scale up and can use the same token across many endpoints, many servers. So that's the beauty about that. So what we've talked about here today, and what we're now going to go on to in the next video, so look out for that, we're going to go and implement what we've discussed here today. So we're going to go back to our JSON web service with our basic authentication. We're going to change our authentication so that when you log in, you'll get a JSON Web Token back, and then we're going to have some endpoints that require a valid JSON Web Token in order to be able to respond to the data. And if you call it without a valid token, you're denied access. If you call it with a valid token, then you get the data back. So that's what we're going to go have a look at next. So this is Software Pulse, building Java desktop applications, and I'm John McNeil, and hopefully you found this video informative. Hopefully I'll see you in the next video.